sir. See, this is another board. It's an electronic board which actually used for teaching the students the forward bias action of our diode, and which ultimately gives expression for rectification. They are getting two types of rectifiers, half wave rectifier and full wave rectifier. The action of half wave and full wave rectifier and their output characteristics all can be displayed here on the board and can be compared with AC, and what is actually happening in half wave rectification and full wave rectification, and we can compare at a glance all these three or four waveform in this device. Now see, now here two diodes are kept. One is forward bias and the other is reverse biased. But they are provided with AC of 6 volt from a step down transformer, and a student asked to tell whether these two are glowing or not. They will tell both the bulbs are glowing. But actually one bulb is glowing, other is not glowing. No one will believe if we simply tell that one is glowing and other is not glowing, because our eye has a property of persistence of vision. In our eye, any image falling will be lasting for 1/16th of a second. But in the case of AC of 50 Hz, we have studied already 1/100, that is half of that one wave, that direction of electric current reverses. That means in every 1/100th of the second the bulb glows and one bulb switch off and other is on. So when bulb red LED it is working, when blue bulb will not be working. How can we make it visible to student? We are making a simple method of rotating this drum here. That roll is rotated, which is connected to the same circuit. Parallel connection is there, but one is stationary, other is going to be moving. So it is easily recognized that when blue patch of light is there, no red patch will be there in the same line. So alternatively, the blue and red glows. Due to persistence of vision, our eye cannot make out it. Once it is moving, we overcome the persistence of vision and we see that pattern steadily. When it is moving, we can see one red, just above red, no blue, then red, blue. Alternatively, it is 1/100th of the second how long it can or how far it can move, and we will get that patch. If it is a little bit faster, that patch will be little bit longer. If it is slow, the patch will be smaller. Now we come to the next part, half wave rectifier. What is happening in the output of a half wave rectifier? Here one diode is used, and see one negative half is removed from the circuit. So we get only the red with a gap. So one pulse positive, the negative is missing, and we lose one half of that wave nature of AC. Now suppose we are using this again, another half wave rectifier, but there is a provision, one more diode is there. I am going to introduce one more diode, which is going to be then a full wave rectifier. So the nature of waveform of full wave rectifier, student can very easily understand. One half which is missing is replaced by the next half. Both positive half we get to x-axis side, but even now we have got some dots there. They are called null points. That null points, due to our waveform, that x-axis, when it is touching, there will be no voltage. The reversal will take place at x-axis level. Waveform will very easily give you that explanation of null point. Now how can we get a smooth or steady DC? We are using a capacitor in the circuit. When capacitor is storing the electric current, it is giving to the external circuit. All this variation or fluctuation of DC is remedied, and we get a steady EMF. Let us see what will happen if I switch on this capacitor. Now we get a clear or smooth DC. So we can compare easily on the same disc AC, half wave rectifier, full wave rectifier, with the capacitor and without capacitor. So student get a very clear-cut idea. Now we have done this by moving the device or moving the light. We can overcome persistence of vision another way, that is by reducing the frequency. So we can have our own frequency. This frequency we cannot vary. This is of 50 Hz given by the our country, 50 Hz 230 volt. volt we can reduce or increase, but we cannot change the frequency. So we have to have our own device to change the frequency by making our own AC. It is done using a device called mechanical inverter, which is very simple, designed by myself. One thing, which we can tell later. First we can tell. Now, this mechanical inverter is a device where we are using DC, the source here, a battery 9 volt, and is converted into AC from the output. It is using two full rings and half rings or split rings, and output is given from the split rings. So AC is developed from this DC, is our own AC of our own frequency. Now let us see how it will work. And is connected to a motor, and I am going to turn the motor. The motor is slowly moving, and this shaft is moving very slow. You can see the variation of halves, positive and negative half. Now, if this speed is increased, now you might have seen the effect of the speed on the bulb. If it is of 50 hertz, 1/100th of the second, this conversion is taking place. But we cannot make that much of high speed here. But you can very easily see the variation of speed and the frequency. This gives the impression that both the bulbs are glowing. Same thing can be used to study the working of a bridge circuit. Now when bridge circuit is working, we will get an idea all the four will be conducting at a time, but it is not like that. Only one pair of diodes are working at a time to get that full wave rectifier circuit output. Now I am reducing the speed. You can very easily see which pairs are working now and compare with this AC. Now if the speed is increased, we get an impression all the four are working at a time. So this is the advantage of mechanical inverter, and we do by moving that shaft slowly and fast because we are varying the frequency. So frequency matters. To overcome persistent vision, we can have two methods now. One is move the source, next is reduce the frequency. In both the ways it is made here to make the student understand the working of our bridge circuit and AC, how it works actually in slow frequency or low frequency. Thank you very much for covering this particular item, and I hope this will be much useful to all the viewers, especially students of our 10th standard or even +1, +2 level, to understand what things are happening in the case of rectification as well as in our electrical wiring. Thank you very much.
Thank you very much, sir. Thank you.